Homework 14, section 7.2, applications of the standard normal distribution, video 5. We've spent so much time converting measurements to z-scores that it's, you might wonder, do we ever have to convert a z-score back into a measurement? And the answer is yes, but before we get into the reason why, let's just take a look at an example of converting one. I'm assuming that everybody knows what an IQ score is. IQ is an abbreviation for intelligence quotient. It's an attempt to measure people's intelligence levels. Assume IQ scores are normally distributed with a mean of 100 and a standard deviation of 15, meaning that the average IQ is 100. If a person's z-score is 1.38, what is their IQ? Well, we have a formula for calculating z-scores. It's z equals x minus mu all on top of sigma. But in this problem, we already are given a z-score and a mean and a standard deviation, and we're being asked to calculate the measurement. Now, we could substitute those three values and create an algebraic equation to solve. But why don't we take this formula and manipulate it so that it says x equals, which is what we want to know. In other words, why don't we do the algebraic manipulations once, create a new formula, and not have to do the algebraic manipulations again in the future? If we want to solve this for x, we have to get rid of everything around it, starting with the sigma. So to get rid of something that's divided, we can multiply. So let's multiply both sides of this equation by sigma. They would cancel on the right, and that would leave us z times sigma equals x minus mu. And then to get the x by itself, we could just get rid of the mu. Since it's being subtracted, we could add it to both sides. So we'll add mu to both sides. The mu's would cancel on the right. That would leave the x by itself. And so we get the formula x equals mu plus z sigma. It's the same formula as before, just rearranged to say x equals instead of z equals. But if you think about it, it makes perfect sense. Because what does a z-score measure? A z-score measures the number of standard deviations above the average that you are. So this z is the number of standard deviations you add to the average. So it actually makes perfect sense. And now that we have this version of the z formula, let's use it on this problem. In this problem, we're told that the mean is 100, the standard deviation is 15, and the z-score is 1.38. So let's just substitute everything and get x equals 100 plus 1.38 times 15. And if we got out a calculator and did the math, could probably do it without a calculator, but don't want to waste our time. We get 120.7. And so if your IQ is 120.7, then your z-score is 1.38 and vice versa. So converting a z-score back to a measurement is pretty straightforward. It's basically the z formula converted to say x equals, and then you just substitute the mu, the z, and the sigma.